So now let me share. So basically, can you see my screen now?
Yes, yes.
Okay. So we try to develop this prediction code, and further that we find out this type of a map. Okay. So in this map, we find out that blue color basically it's a water body, as well as this type of red color indicating about the build up. Okay. And yellow color is the barren land, and we also find out the some pink color. Okay, pink color shows as a cropland. Okay, so this code we try to develop, and further we also try to calculate the area. Suppose how much build up area we find out the 2034. How much things we can get is supposed 2034. Okay, so this is our data for 2034. We find out that this is the water body, and this unit is the, I think, okay, let me check the unit. It is a hectare, or this unit is okay, this unit is a hectare. We calculate the multiply 1 inverse 4. That's why it's a hectare unit. Find out that a hectare unit. Okay, so this is our one kind of prediction result. So further from here, you can simply calculate the percentage. Suppose how much percentage for that water, how much percentage for that build up or crop plan, other things we try to. And this map we try to display as a prediction map. Okay, so in this prediction, basically it's depend on the previous change detection. Okay, suppose we already make the map for 2014 to 2024. Based on the change detection, it extract the pixel, and further applying the random forest machine learning model, and then make the classification for the future. So in this case, we try to, okay, I will show you the method, just a minute. In this method, we are just input. Suppose we are just inputting the two land use land cover map as a variable, mainly 2014 and 2024. Okay,
Okay.
not only for that, these two map how change. Okay, how it will be changed. Suppose water to build up to water body, so this is the change. Okay, so this change we also consider the transition. Okay, so that's why after importing the two land use land cover map 2014 to 2024, as well as we also input the change map mainly these two change map. Okay, land use 2014 to because we make the prediction based on the change. Okay, so we also calculate the change. Okay, and this is our formal factor. Okay, this is the formal factor, and this type of factor called as the informal factor, such
Okay.
as dam data. Dam basically is the elevation, high elevation, low elevation. Okay, because people when make the settlement, they are also think about the elevation. People always try to make their settlement in the flood plain. It's a very popular, but when it will be for the high hill or hilly region, then people are not suitable for making the settlement or other things. It's not suitable. Okay, but in the flood plain or low elevation, people easily can move or other thing. That's why it's very important factor. Dem is mainly digital elevation model data. So we also take the elevation data. Further, we also use at the slope. Slope mainly it's indicating about the gradient or angle from the sea level. Suppose from the sea level, how much angle it create. It create the it talk the slope. Okay, as well as you also input the distance to river. Distance to river means that where is the high distance, where is the low distance from the river, and further from this region, Suppose in the distance to river, people are not suitable for making their settlement because all time they can be river bank erosion or all time for flood. So this type of risks in the distance to river. So that's why people always try to make their settlement distance to far from the river. So that's why it's the another important factor for um, prediction. Okay, and then distance road. So people always try to make their settlement near to the road. Okay, so that's why they can easily make the communication. They can easily move to their vehicle, easily go to the communication from one place to another place. So that's why people always try to make their settlement near to the road, not far from very road. So that's why it's the another very much factor for prediction, distance to road. Okay, because people common nature to make their settlement or make their construction or make their any household near to the road. So that's why they can easily communicate from one place to another place. Okay, as well as we also consider about the aspect is one kind of it's the follow direction, it indicating about the follow direction. It can be water follow direction or any kinds of follow direction for on the surface. Basically it indicating about the hydrological one factor for aspect. So we also use here the aspect as a parameter. So basically land use land cover prediction is not only defend this type of factor, it's defend lot of factor is available. If you want to check the different types of scientific paper, then we can easily find out the lot of things, lot of idea about this. But commonly people we are use this type of factor and we can create the prediction map. Okay, so this type of factor input, then we further apply our EMS 2014 and also apply our land use land cover 2014 and 2024. Okay, and then we create some property. So this is our prediction property. So basically start, transition, elevation, basically this type of thing, start, transition, elevation, this is our property. Simply write in here all of name together. Okay, we are just write in here, and predict name int. Okay, so in this case we try to predict based on this 2 year land use land cover. Okay, and then what we can do, just simply extract the pixel value. Suppose in this time we extract the 3000 pixel value, all of product. Suppose all of band, start, transition, elevation, slope, all of things we try to extract the pixel value. How much? 3000. Okay, and I put the scale 10 and then transition, and randomly we distribute the data. Further we simply spill the data, 80% data for train and 20% data for test. Okay, and then we try to check the train test, and further we try to make the model random forest. Okay, so in this random forest model we train our 80% data. This data we try to train. Okay, 80% data we try to train, and then we use at the predict name mainly int. Okay, this is the int. You can see predict name basically int year in 2024. Okay, and further property name basically all of property. You can see property name, all of property, start, then transition, elevation, slope, all of property we consider in our model as an input. Okay, in the random forest model we are just input, and further we check our accuracy. So basically rest of the 20% we call and classify and model prediction. We just use here the int and predict. Okay, so int basically year of 2024 and predict for the future, but we are not define which year I want to predict. So first of all we check the accuracy, and then we put our year, which year I want to predict. Okay, so for doing this thing we check the accuracy. This type of accuracy you can simply check the accuracy or kappa accuracy. We can simply check. So we find out the result look like that. Here you can see get the result 0.99. Okay, so basically this model can be predict 0.99 or 99%. It can be predict for the kappa accuracy or also overall accuracy. You can get it. And you can see also you can get this type of things. Okay, this is the confusion matrix table for prediction model. Okay, this control method mainly prediction model. Okay, and further we try to set the variable for predict year of 2034. So in this case, we are simply call the same all of land use, land cover, change map, this type of things. In this case, in the image portion, we can write the our expect year. So which year I want to predict. So
Okay.
I want to predict year of 2034. Just put this year, and then further we simply call our show our visualization. Okay, basically this variable connecting with our model. Okay, connecting with our model, and then further we can get this type of land use, land cover map. Okay, so in this case we are applying the random forest algorithm, and then we predict this type of things. Okay, and how much training point we can get for the train or test, all of those things can easily get it from here. You can see I also write it in here. So in this case we try to use here the train sample, this is the train sample, and this is the test sample. Okay, and this is our accuracy table, and further we just use this model. Okay, and what is the input we can use in here in our model. So in this model we try to put here all of model. Basically you can see for that start land use, land cover 2014 2024. Then we try to put here that your dam data, slope, aspect, distance to road, distance to river. Okay, all of parameter we can write in here. Okay, so this type of parameter mainly extract the pixel value, and how much pixel value we can continue, 3000 pixel value. Okay, 3000 pixel value. Okay, and further we try to predict this type of things. Okay, and we can get this type of things. So this is our prediction map. So now further you can simply use it in your work, and further you can also write this type of things. I was here, you can see you can also get, I also individually try to write the code look like that. You can see we can get find out our water how much area. Also you can see the cropland build up, and also this is the, okay, so this is the 2 is the barren land, yeah, 3 is the build up. So this is the build up area. So we find out that the build up area you can see, and also you can see the from the map we find out that cropland is in decreasing. Okay, day by day cropland is decreasing. If I open the map, suppose land use, land cover map 2024 14 and 24, then you can easily compare their visualization from here. Suppose this is the map for 2034. So now this map is the 2034 for prediction map, as well as we are also use this type of input here. You can see 2014. So this is the map for 2014, and this is the map for 2024.
Okay.
Okay, as well as we just simply predict from here. In the prediction we find out this type of map. Here you can see it decrease the some uh, cropland area. Okay, decrease the cropland area, and lot of people also set up the new settlement. Okay, suppose you can see this type of people, there is no settlement, there is no red color. This type of place there is no red color, but in 2034 we find out that this type of place we find out the settlement, because this is the more suitable place for making the settlement or household. Okay, so that's why it show we can get this type of result. So further you can simply use this map, and further you also calculate the accuracy. We already calculate the accuracy, I calculate the area. Okay, then you can simply, you already calculate the two previous land use, land cover area. So further you can simply make the compare how much percentage increasing or decreasing in the future. So when you write the result and discussion, simply write it. Okay, so this is the one process we try to add the machine learning model random forest and make the classification. Okay, so do you have any question, you can ask me.
Sir, there are some things. There's some things are there that we have to calculate the slope. We have to calculate
Yeah, yeah.
the tangent and distance from river, distance to. Can you see the? Can you just go for just go in the code?
Yeah, so you can see distance road. So this code, okay, so here you can see basically we already,
So there are
yeah,
some parameters
yeah.
that we taken like uh, come below, uh, terrain or more come below. This is DM. This is for DM slope aspect and other things are also there. Distance from river,
Yeah.
distance from one thing more, distance from road. Come below, sir. This is the distance to river, and also come below distance to road map. Distance for road map. So there are some distance to river, distance to road map, DM slope. These are the parameters.
Yes, yes.
Okay. Uh, uh, there is any video or other thing to read out more uh, for these particular things.
Okay, so you can simply read some paper. I also send you. Just suppose. Okay, let me open the Google Scholar. And you can
You have some recorded class for this prediction in this uh,
recorded class is not available, but I also manage it, no problem, because I also take the class for others. Suppose I
yes.
simply search LULC future prediction. Simply search. You can see here dynamics, future prediction. Okay, monitoring prediction, land use, land cover changes. Okay, so I just try to open it. So this is the one paper. Basically, this one kind of the book chapter is not freely available. Okay, let me open.
This is okay.
Okay, so this is the one kind of paper. So if you okay, so basically in this paper, there okay, so in ancient land use land cover map, and also they are use the Markov chain method. Okay, so CA Markov method. Okay, so maximum paper work with the model. Okay, so previous class I also discussed about that tart set software. Okay, so maximum paper mainly they are used at the Markov chain method, used to establish the transition probability matrix or cellular automata. Okay, this type of model they are used here to predict. Okay, and you can see we also try to check the suppose method, what the method they're using here. Maintenance method. Okay, so basically they are take the land use land cover for build up barren soil, cultivated land, vegetation, water body, floodplain, and also rural settlement. Okay, and they are make the map 1900, 2000, 2008. Okay, image analysis their user it, and okay, and then further trend prediction, land use land cover changes, land use modeling. Okay, so Markov chain analysis, you can see that user the Markov chain analysis or MCA or cellular automata technique to predict land use cover. They are used at the Idrisi Taiga software. Okay, so it's one kind of another software. Okay, or TarSet is also okay. So basically this user the Idrisi Taiga software, one of the basic assumption of the MCA, land use land change. Okay, so in this time they are not used at the random forest algorithm. They are used at that Idrisi Taiga software. It's very previous work, I think. Okay, and in this time you can see here they are also make the accuracy assessment. This is a result and discussion, and they create this type of map 1900, 2000, then 2001 and 2021. It's simulated. So basically it's the prediction work for the 2011. So it's very okay. This is the one way. They are used at the Markov or cellular automata method. But we try to focus on random forest.
Sir, basically put data legends in this particular code also.
This one?
Sir, put data legend code in this particular code also, in prediction code.
Random forest. Okay, random forest, cellular automata, modeling, approach for land use language changes, dynamic prediction language changes, okay, machine learning technique. Okay, try to open it. In this paper, they are used at the multispectral remote sensing GIS based decadal land use land cover changes, user prediction using random forest tree. Okay, they are also used at the random forest. It's also not freely available. Not available in here also. Okay, so maximum paper they are used at that model. You cannot use the random forest. You can see they are used at the CA method or also other method. Okay, CA Markov model and random forest. Okay, they are used at the two things at the same time. CA Markov as well as also used at the random forest. Modeling land use and predicting using CA Markov. So you can check the method. Yeah, study area. This is the study area. In the method,
Uh, just sir,
random
I
forest.
want to just I want to gain knowledge about the
Random forest.
parameters parameters that we are using. Just that.
Yeah, we have to find out this literature. CA market reliable for method for the predicting language. It has been it's okay. The transition, yeah. So this is the supervised classification language cover change analysis, post classification, CA Markov model, transition suitability of maps of land use land cover, model evaluation, and then kills. Okay, it's no. Find out, suppose simply search LULC, LULC, LULC prediction factor. LULC future prediction factor. Suppose I put it there. Okay, so if I show you my running work, suppose. Okay, so this is my running work, and it also published as soon as possible. I try to submit it. So now it's the modify. So we in this paper we also try to add that. I'll show you that. Suppose you can see this is the land use land cover map. We try to develop in here Suppose study area, yeah, it's not, yeah. Material. Okay, so here you can see this is the one kind of figure. So in this time, we try to use here independent variable. Basically, land use land cover 2013 and land use land cover 2023. It's an independent variable. Okay,
Okay.
and this
Okay.
is the dependent variable. Basically,
Okay.
dam, distance to road, distance to river, hillshade, slope, aspect. Okay, so
I
in this
want
time,
I want to read these particular dependent variables. So I gain knowledge for these particular dependent variables.
yes, yes. So it's a independent and it's a dependent. So this type of future prediction depend on this dam. Okay, depend on the distance to road, distance to river, hillshade, slope, and aspect.
What is dam, sir?
Is the elevation model or elevation, high elevation, low elevation? Is it?
Elevation model. Okay.
Okay.
You describe these particular things.
It's not yet publishing. So after publishing, I also shared this paper with you. Then you can easily get it how we can improve it. Okay.
Vegetation.
Yes, so there are a lot of work. Okay, in the next month, we also try to submit this paper. This is our prediction map here you can see. Okay, we find out that agricultural land will be decreased day by day. We find out the very low agricultural land. Okay, also we find out that barren land is also decreased. Okay, settlement is also increased. This type of red color is also increased in the cost. Okay, and we also find out that barren land. Okay, so this is the one kind of work we also continue working. So in this time, we are also applying that CNN. Okay, basically try to apply. We try to apply the model for prediction. But in this case, we are just applying the random forest, and this type of work is not published yet. I think they are not publishing any paper. So maximum prediction paper is published by using the model. It can be Markov model or it can be CNN model. Okay, they are used at the different types of model, and then they are publishing this type of work. But this random forest is also okay. This time we are just input this type of things, this type of parameter which influence the land use, land cover change. Okay, and then we try to develop it.
Okay, sir. Only I need some theory about dam or other things. What are the parameters in this particular? Only
Parameter
theory
description.
that I should read, or there is some any other online content that I could gain the knowledge about these particular things.
Okay, let me find out just a minute.
Code is okay. Code is okay. I can understand. But if someone asks that why these particular parameters are taken in this particular code, then what should I
Yeah, yeah, yeah.
and for then what should I answer to this?
Okay, so this is another paper. So just a minute, I don't find out the factor influence. We just write the paper without it. LULC, future. Okay, so here you can see now. Can you see my screen?
Yes, yes.
Okay. So here you can see here in the figure 4. In the figure 4, parameter used for land use land cover prediction. They are used here the dam of study area, then slope, then aspect, distance to from road, distance from water body, and
Yep.
population density. Okay, and also add this type of map in here. If you want to read the paper, then I hope you can easily get this idea how they use. Suppose you can see preparation and the parameter for the future land use land cover simulation. So in this study, considering the available data and other land use pattern, 6 parameters were selected for future prediction. Among this parameter, there is the slope, elevation, then were generated from the NASA SRTM data, and topographic features such as elevation, slope, aspect play a crucial role of transformation of the land use land cover land use land cover. Okay, we can see that also write about that crucial role for the land use land cover platform. And also say about the citation about the paper. Okay, so where they get the information. And furthermore, distance to major roads are calculated using the vector layers obtained from the street map, and the proximity urban network is it's a pivotal aspect for the urban development. We can see. Okay, so I will randomly which I talk. It also right. People easily immigrate to the city area for their work because distance to river map or distance to road map. In the distance to road map, they can easily visit from one area to another area. Also, you can see the distance from the roads can significant influence using the change prediction. Distance from water body population data were downloaded from here. Population density significant impact of the land use land cover change data here. Okay, so basically from this paragraph, I hope we can easily got your answer. Okay, how we use this type of parameter. Okay, so you can also use it as your reference. Okay, you can also when you write the paper, then you can also use it as a reference and also put the citation. Okay, and you can see that also create this type of parameter in here. Okay, and you can see how they apply the model. So basically in this time they are applying the ANN, artificial neural network model, but we are just apply the random for rest algorithm, machine learning. And they are also using the Molas is one kind of another software. They are using the Molas, but we are using the Google Earth engine and then predict. Okay,
Okay.
so you also try to read the paper and then you also get the idea. So basic concept is the same. Distance to river, people not suitable for living their settlement because in the river there are a lot of river bank erosion or flood happened in the river. Okay, so that's why people always try to put their settlement distance far from river, at distance to road, because when you set up your settlement or household or industry, people easily move when they are set up in the near to the road. People easily can move from one place to another place. Okay, this type of crucial rule for working with the future prediction, and there are a lot of region. So you also try to read the paper. Okay, I'll try to find it after finding a lot of paper. So this type of paper you can also find out. The lot of paper is available regarding this type of way. Okay. So basically, I also send you this code link. You also try to check it further. Okay, and I hope you also get the idea how we can easily write the code. Okay, basically, we try to input all of those things and also apply the random forest model. Okay, and why I use this type of input as a factor, you can easily get it from this paper. Okay. So you also try
Okay.
to study and also try to make the payment for future prediction and then get the code, and further you also make the calculation other things. Then I hope you can easily get the idea how it will work. Okay.
Okay. Okay, sir.
Okay. Yeah.
Sir, basically, if I going to write those the research papers for this particular area for change detection and after that prediction, then what factors that I have to consider for
Uh, yeah.
accepting those particular papers?
I don't understand your question.
Uh, After code, it is a code. After code, after taking results, I am going to write research papers for it
Yes,
for
yes. Yeah,
change detection prediction.
yeah, yeah.
So, what type of things that I have to consider when I am writing the research paper in these particular areas?
First of all, you make the your data and result you ready. Data and result you ready. Then further you try to write the result and discussion. And further move to the uh, introduction and then move to the abstract. Okay, step by step, right?
First, what I have to do?
First of all, you write the data and method, then result. Okay, so I'll also show you the sequence. Just a minute. So first of all, when you write it, you write the data and method. Okay.
Okay,
After completing the data and method, move to the result. Okay. Then put the discussion. Okay, this is the another discussion. Okay, data, method, result, discussion. Then move to the introduction. Introduction. Okay, and then put here and then write the abstract, and finally write the conclusion.
okay. So,
Conclusion.
what will be the method for chain detection? What will the method of chain detection in our code that we use? Smile random forest classifier, and after that, what should we do? What we do in the chain detection method?
Change detection method, we take that tool and use then cover map, and further we try to make the extract the pixel value, and then we make the transition water to water to. So I think it also better you try to read some paper. Okay, so basically concept is the same. In this case we are using the coding, but other people they are using the randomly other software. Okay, but our concept will be same for the data or method. Okay, this concept is the same. Okay, so I think it also better you try to read some paper and then find out how they write it, how they write this type of thing step by step. Okay, data and method, how they write. And you also, when you face any problem you don't understand about that data, how we can easily get the data, they write this thing, how I can write it. So then I also guide you, no problem. And is there any way for collaboration? If I help you, then I can get the co-author of this paper, or what is that? Is it any project work or?
Sir, it is my PhD work. I have to produce. I have to publish some.
Okay,
Uh,
for the PhD work, okay, so after completing your degree, then you also try to publish, I think, or what do you think about that?
Sir, basically during PhD, during duration during for fulfillment of the PhD degree, need I need papers. I need to publish research papers in
Okay,
the
understand.
particular journals in the good journals like Q2, Q3, or Q1 or Q4.
Okay, okay, okay,
It is
so do you
yes.
have any supervisor or not?
I have supervisor. I am doing PhD from Manipal University.
Okay,
But my supervisor is because I am from CS, computer science background.
okay,
I'm not from geography or geography background in which these particular softwares are used. So
okay,
basically, uh, the my guide is not very much aware about these type of works. I have to found a person which is very aware in these particular type of works, so that he can help me to write the research papers and publish the research papers at the same time. This
Okay,
is
okay. Okay, no problem. First of all, you try to write the step by step, because write is very important part for publication. The
yes,
step
yes,
by step you write, and your data and your result is almost ready, because when you get the data, we already make the map, we already make the prediction. Okay, we
yes,
already
yes,
do all of calculation. So now just
yes.
represent it carefully. Then I hope,
Okay.
and else write the full paper carefully. Then I hope you can easily find out that publish it more better journal future. No problem.
Okay, you can assist any. You can assist me for this particular writing the research paper. If I
Okay, I also guide you, no problem. But then for that we also, you can also keep my name as a co-author. Then it also beneficial for me, because I also
okay,
work with
okay,
this sector. No problem. Okay. So for the
okay,
writing
okay.
part, I also guide you, no problem. If I get the this co-author, then I also guide you, and it also more better. Okay, I also guide you on this, no problem. All of a step, because I already completed. You can see, this is
Yes, yes.
my ongoing work. So I already write all of my things. Okay, so now it also reviewer. So I need to some correction. Okay, this type of things I also need to reference. Okay, so that's why it also working processing now, and you also do for the same types of work, then I hope I also can help you. Okay, but for
Uh,
that you also just keep me as the co-author of your paper, then it also better for me also.
okay, sir. I just asked to my guide that
Yeah.
the
Okay.
for the co-authorship of you,
Okay.
and after his confirmation, I will ask you.
Okay.
I will message you or text you about this.
Okay. Okay.
And
Okay.